Hello viewers, in today's session we are going to discuss one important problem from limits involving the fractional part function and greatest integer function, right? So here we are given a function f of x which is equal to fractional part of x divided by greatest integer of x minus 1, right? So here the curly brackets denote the fractional part function, and the brackets, these square brackets denotes the greatest integer function, right? So here we have to find the right hand limit and the left hand limit of this function when x tends to 1, and we have to see whether the right hand limit and the left hand limit it exists or not. And if it exists, then let us calculate the values of right hand limit and left hand limit. So here what we do, will make use of the definition of fractional part function and greatest integer function to solve this problem, and how we can find out the right hand limit and left hand limit using the concept of the definition of fractional part function and greatest integer function. So let us start. So here we have the point 1. So here we have x is equal to 1, right? So when we calculate the left hand limit, it implies that we are approaching from the left of x is equal to 1. And when we calculate the right hand limit, it implies that we are approaching towards x is equal to 1 from the right of x is equal to 1, right? So here when we find out the left hand limit, we take a point which is very close to x is equal to 1, but it lies towards the left of x is equal to 1. So this point is given by 1 minus h, right? Because here we have to find the limit when x approaches to 1. And similarly, we take a point towards the right of x is equal to 1 and very close to x is equal to 1. So this point may be taken as 1 plus h. So here we have a quantity h which is infinitesimally very small, right? So this quantity h is almost equal to 0, but it is not equal to 0, right? So it is very close to 0, and it is a positive quantity. It means h is greater than 0, but it is less than 1. So we can say that h, it lies between 0 and 1. So here for left hand limit, we take the notation that is limit x tends to 1, and here we have a negative sign, then we have f of x. So this negative sign shows that we are approaching from x is equal to 1 from the left of x is equal to 1. So all the values which lie towards the left of x is equal to 1 are less than 1, right? So here we have less than, x is less than 1, and here we have x greater than 1. So it implies that obviously 1 minus h is less than 1, and here 1 plus h is greater than 1. So now we take here x is equal to 1 minus h. When x tends to 1, then obviously h tends to 0, because then we have this point x is equal to 1, right? Because when h tends to 0, then we have the point x is equal to 1. So here we have the left hand limit, limit h tends to 0, f of x, x may be replaced by 1 minus h, right? So now we have limit h tends to 0, and f of 1 minus h can be obtained by replacing x by 1 minus h. So we have fractional part of 1 minus h divided by greatest integer of 1 minus h minus 1, right? Now here we'll make use of one important relation between fractional part function and greatest integer function. Now see, the fractional part function is defined as x minus greatest integer of x, right? So this is the definition of fractional part function. So fractional part of uh, 1 minus h may be written in terms of greatest integer function. So we can now write 1 minus h, then we have minus greatest integer of 1 minus h, right? Because we can take x is equal to 1 minus h here. So the fractional part of 1 minus h is 1 minus h minus greatest integer of 1 minus h. So here this minus 1 and 1 get cancelled, and we have simply greatest integer of minus h. So let us solve it. We have limit h tends to 0, right? And now here we have 1 minus h, and let us see what is the value of greatest integer of 1 minus h. Now see, h is infinitesimally very small. It is a very very small quantity. So when we subtract h from 1, then this quantity is greater than 0, but it is less than 1, right? So the greatest integer of 1 minus h should be equal to 0 by definition of greatest integer function. So here we have 0. Greatest integer of 1 minus h is 0. And here we have greatest integer of minus h. Now see, h is greater than 0. So obviously a negative h is less than h is greater than 0. So negative h is less than 0, right? And when we have minus h less than 0, then the greatest integer of minus h should be equal to minus 1, right? Because this quantity minus h, it lies between 0 and minus 1. So our minus h, it lies somewhere between minus 1 and 0. So greatest integer of minus h is minus 1, right? We can also prove that minus h lies between minus 1 and 0 by using this inequality, right? So if we multiply throughout by minus 1, we'll get 0. The direction of the inequality get reversed. So we have minus h, here we have minus 1. So we can rewrite it as minus 1. Here we have minus h, and this is 0. So this minus h lies between 0 and minus 1 and 0. So the greatest integer of minus h is minus 1. So here we have minus 1. So now we have limit h tends to 0, 1 minus h over minus 1. This can be written as limit h tends to 0, h minus 1, right? So here multiplying these two numbers by minus 1, we have h minus 1. So when h tends to 0, then we have 0 minus 1, that is minus 1. So the left hand limit of this function when x approaches to 1 is equal to minus 1. Now let us find out the right hand limit. So the notation is limit. Here we have x tends to 1 positive. Here we are taking the positive sign because 1 plus h is greater than 1. And here we have f of x. So now we have limit. Now we can take x is equal to 1 plus h when we find the right hand limit, right? Because all the values of x are greater than 1. So we have x is equal to 1 plus h. So when x tends to 1, then obviously h tends to 0. So now this limit can be written in terms of h as h tends to 0 f of 1 plus h, right? And here we have limit h tends to 0, f of 1 plus h can be written like this, the fractional part of 1 plus h. Then we have greatest integer of 1 plus h minus 1. And now we have limit h tends to 0, fractional part of 1 plus h is 1 plus h minus greatest integer of 1 plus h using this definition. And here we have greatest integer of simply h because 1 and minus 1 get cancelled. Now see, here we have greatest integer of 1 plus h. Now see, h is infinitesimally very small. So when we add a very small quantity to 1, then 1 plus h is greater than 1. It is slightly greater than 1, but it is less than 2. So by definition of greatest integer function, greatest integer of 1 plus h is 1, right? So here we have 1, right? And see, h, it lies between 0 and 1. So the greatest integer of h is equal to 0. So now we have limit h tends to 0, 1 plus h. Then here we have minus 1, greatest integer of 1 plus h is 1. And here we have 0. So now this one and this one get cancelled. We are left with limit h tends to 0, h over 0, right? And we can easily see that this limit, it doesn't exist. So we see that the left hand limit of this function when x approaches to 1 is minus 1, left hand limit is minus 1, and the right hand limit, it doesn't exist. So we can safely claim that the limit of this function when x approaches to 1, it does not exist, right? Because the limit x tends to 1, f of x, it does not exist. Because for the limit to exist, the left hand limit and the right hand limit should be finite, and they should be equal to each other. But in this case, although the left hand limit is finite, it is minus 1 and it exists. But the right hand limit, it doesn't exist. So it is not finite, right? So there is no question of equating these two quantities, and hence we can say that the right hand limit doesn't exist, the left hand limit, it exists, and it is equal to minus 1. And overall, the limit of this function when x approaches to 1, it doesn't exist, or it we cannot find out the limit.